Welcome to Zia's Stoichiometry video, featuring the man, the myth, the legend. In our first equation, we're given 5 grams of magnesium and 10 grams of hydrochloric acid. Then you need to notice that this is a single replacement reaction. Then you need to balance it. I put a 2 in front of hydrochloric acid because now there's 2 chlorines on this side, 2 chlorines on this side, 2 hydrogens on this side, 2 hydrogens on this side, and 1 magnesium on both. Then we need to find the moles of the magnesium and the hydrochloric acid so that we can figure out which one is the limiting reagent. We divide 5 grams by the molar mass of magnesium, get 0.206 moles, and then we divide 10 grams of hydrochloric acid by the molar mass and get 0.274 moles. This doesn't necessarily give you the limiting reagent because you need 1 of these for every 2 of these. So, to find the limiting reagent, you have to divide this by 2 so that then you get 0.137. You have to compare these and you see that the limiting reagent is hydrochloric acid because it is much less than the magnesium and you'll run out of it faster. Then you have to find the excess of magnesium. So you take 0.206 minus 0.137 and you get 0.069 moles of excess magnesium. To turn this into grams, you take 0.069 and you multiply it times the molar mass and you get 1.677 grams of excess magnesium. Now we need to find the grams of hydrogen and magnesium chloride. So first, you take 0.27 moles of the limiting reagent, and since it's a 2-to-1 ratio, you divide that by 2. You get 0.137 moles, and you times that by 2 because of the molar mass. You get 0.7 grams of hydrogen. Now for magnesium chloride, you take 0.27 moles of the limiting reagent, you divide it by 2 because it's a 2-to-1 ratio, you get 0.137 moles, but then you need to multiply it by the molar mass, which is 95.197. You get 13.04 grams of magnesium chloride. Then you need to find which one was reduced, which one was oxidized, and which one didn't change. You do this by looking at the charges on both sides of the equation. You see that magnesium went from 0 to +2. That means magnesium was oxidized. You can see that hydrogen was reduced because it went from +1 to 0. And chlorine did not change because it's a -1 on each side. For the percent composition of magnesium chloride, you need 1 mole of the molar mass of magnesium and 2 moles of the molar mass of chlorine. Then you get the total, which is 97.1, and you divide both of them, giving you 25.5% of magnesium and 74.5% of chlorine. Now we're given a different percent of each, so we get 20.19 of magnesium, 53.17% of oxygen, and 26.64% of sulfur. Then we divide these by the molar mass of each, and we get 0.83, 3.32, and 0.83. Then we divide it by the lowest one, which is 0.83, so you get 1, 4, and 1, which gives you 1 magnesium, 4 oxygens, and 1 sulfur. To turn this back into a compound, you can change it into magnesium sulfate.